Hello again, physicists. For today, we're going to do something that you should already know. It's a prerequisite for being in this course. I'm talking about trigonometry. And even though you should know this, I still think these are such important fundamental concepts, it's worth spending a few minutes to just go over them and make sure we are confident in our skills with respect to trigonometry. So let's begin. You'll hopefully notice that over here I have a few triangles, and altogether we have 1, 2, 3 triangles. And we want to give this triangle a specific name. We would probably want to call it the right triangle. Why? Because of this guy right here. That is our right angle, or 90-degree angle. And hopefully we all know that that little box symbol in that corner there denotes the fact that that is a 90-degree angle, and therefore this is a right triangle. So really basic stuff to begin with. Let's actually get into the more important things. And I'm going to go back to something that my teacher in the past at least would always fondly refer to as Sohcahtoa. And maybe you've seen this in your math class as well. Sohcahtoa. Okay. What is Sohcahtoa? I know, hard to remember. Dig back into your memory. Think about it. What was Sohcahtoa? What did it tell us? I'm going to pause and give you a minute to think about it. Okay, that's quite enough time. So hopefully you were able to arrive at the answer that Sohcahtoa is how we are able to use the trig functions sine, cosine, and tangent to work our way around a right triangle and find out unknown information about the right triangle, such as the sides of the triangle or even maybe one of the angles inside of the right triangle. Now, over on the left, I'm going to first have us look at the top right triangle here. Notice that again, there's my right angle, and I've labeled the sides of my right triangle X, Y, and Z. We also have our two remaining angles inside the right triangle, which I have labeled theta 1 and theta 2. So let's just go through really quick and write out explicitly what Sohcahtoa stands for, because alone it's just a moniker. If you don't know what the meaning is behind Sohcahtoa, it's really just a useless saying. So let's begin with the SO. What does SO stand for? Well, it tells us that the sine, and then this is important, students love to leave this out, the sine of an angle within the triangle is equal to the opposite side over the hypotenuse. And before we go any further, it's very important that we are explicit about which angle we are referring to right here when we're talking about the sine of that angle. Because based on the angle we're talking about, whether it be theta 1 or theta 2, the opposite and the adjacent side can actually be different. And to illustrate that, that's why I have these two other triangles down here. This is the same triangle as up here. It's just now I've only put in one of the angles each time, and I have explicitly labeled which side is the opposite and which side is the adjacent. Remember, the opposite side is always going to be opposing the angle which we're referring to, and the adjacent side is the side that is touching the angle. See how they are flipped here for theta 2 as opposed to theta 1? Got to be very important. If you mix up which angle you're referring to using Sohcahtoa, you're going to have a bad day. So moving on, we have the SO taken care of. Let's look at Ka now. Ka stands for the cosine of theta being equal to adjacent over hypotenuse. And lastly, we have the tangent of theta being equal to the opposite side divided by the adjacent side. So there we are. Very quickly taking care of Sohcahtoa. And when you start using Sohcahtoa, when we get to vectors, I am going to ask that you are very explicit. In other words, that you start by always stating one of these formulas, just as you see them here. You don't want to skip ahead and start plugging things in, because in physics, you need to show every step that you take. You need to make sure you're taking every step. It's kind of like walking up or down the stairs. If you start skipping a step, you're more likely to trip and fall down the stairs, and then Mr. H is going to have to pick you up off the ground and kiss the boo-boo. And I really don't enjoy doing that. So do yourself a favor, don't skip the steps. Now, let's go through and determine things about x, y, z, theta 1, and theta 2 using Sohcahtoa. So to begin, why don't we first just look at theta 1. In this case, the sine of theta 1, notice that I'm being explicit, okay, will be equal to, again, I'm going to start with opposite over hypotenuse. Okay. Now I will rewrite this formula, but now I will substitute in, well, what is the opposite side? What is the hypotenuse in my right triangle? Sine of theta 1 will be equal to, okay, well, looking here, it appears that the opposite side will be over here, and in my triangle, my opposite side is y. So it's going to be y over the hypotenuse, which here's my hypotenuse, so it looks like my hypotenuse is z. So the sine of theta 1 will be y divided by z. And then from here, if we actually had some numbers for y and z, we could go further along and plug them in. But you should always be plugging in your numbers last. Right. Now, let's try expressing what the cosine of theta 1 would be in terms of x, y, and z. So again, I'm going to start with the generic formula. Cosine of theta 1 is equal to adjacent over hypotenuse. Now I will actually plug in what is my adjacent side and my hypotenuse within my right triangle. So the cosine of theta 1 will be equal to, well, my adjacent side would be x in this case, and my hypotenuse would be z. So the cosine of theta 1 will be x over z. Now for the next one, I'm going to ask you to pause and determine for me, express what the tangent of theta 1 will be in terms of x, y, and z, and be explicit, show all your steps. Let's see how you did. So the tangent of theta 1 would be the opposite side over the adjacent side. Again, show the formula first before you put any values in there. Okay, so the tangent of theta 1 therefore would be the opposite side, y, over the adjacent side, x. So the tangent of theta 1 would be y over x. Very nice. Now, what we're going to do, just to make sure we're comfortable with this, is we're going to do the same thing. We're going to apply Sohcahtoa, but now we're going to apply it to theta 2. And note again that because we're referring to a different angle within the right triangle, our opposite and adjacent sides have actually been flipped around. So our result is going to look a little different than what we had when we were using Sohcahtoa for theta 1. I'm going to do sine for you, and then I'm going to ask you to pause and work out cosine and tangent, and then I will reveal the answers afterwards. Make sure, again, you are showing all your steps. So for the sine of theta 2, it will be opposite over hypotenuse. And again, keep in mind that my opposite and adjacent sides have been flipped. So now the sine of theta 2 will be my opposite side, which is now opposite would be x, divided by the hypotenuse, which is z. Note this is not what we had when we found the sine of theta 1. The sine of theta 1 was y over z instead of x over z. So you can see now how just based on what angle we're referring to, we can get radically different answers. At this time, I would like you to pause the video and on your guided notes sheet, just work out what the cosine of theta 2 and the tangent of theta 2 would be in terms of x, y, or z. Go ahead and pause, and then when you're done, hit play again, see how you did. So let's see how we did. To begin with, we are trying to find the cosine of theta 2, which, beginning with my generic version of the formula, would be adjacent over hypotenuse. And then looking at where theta 2 is within the right triangle, my adjacent side is y, and my hypotenuse is z. So the cosine of theta 2 would be y over z. Then for the tangent of theta 2, generically that would be opposite over adjacent. And looking back at my right triangle, my opposite side for theta 2 is x, and my adjacent side is y. So there you have it. Everything that we really need to work on for Sohcahtoa we have done right here. Keep this stuff in your back pocket. It won't pop up immediately in our course, but about 1 unit down the road, we will see this stuff, we will be using it. Our last topic for today will have to do with when we have a right triangle and we know 2 of the sides and we want to figure out what is the third side of the right triangle. So for this case, let's say we know what z is and what y is on my right triangle, but I don't know what x is. And I also don't know what any of my angles are, so Sohcahtoa will not be useful to us here. Can you think of a concept in trig that you've done in the past where you use only the sides of a right triangle to solve for an unknown side? Well, I remember one. It's called the Pythagorean Theorem, of course. And I bet a lot of you remember this one as well. This is a popular thing to remember from trigonometry. So let's figure out, okay, what is the Pythagorean Theorem? A squared plus b squared is equal to c squared, where a and b would be the sides of my right triangle, and c is the hypotenuse of my right triangle. Similar to using Sohcahtoa, we will first use the general application of Pythagorean Theorem, and then we'll plug in specifically what the sides of our right triangle are labeled. So for a and b, it really doesn't matter which I plug in, if x for a or x for b, and same thing with y. I'm going to put x in for a. So Pythagorean Theorem would say that x squared plus y squared would be equal to z squared. And if I was looking for what x was, all I'd have to do is algebraically rearrange the Pythagorean Theorem so that I have everything in terms of y and z. That would mean that I would subtract by y squared on both sides. So x squared would be equal to z squared minus a y squared. And then I would take the square root on both sides. So it looks like x would be equal to z squared minus y squared. Okay. Many people are comfortable with the Pythagorean Theorem. If you have any issues with it, please just bring it up at the beginning of class. We can do a little more review on this, should you wish. That's all I have for trig review. So until next time, physicists, until next time.